Today we've got a pure sine wave inverter from MWXNE. Let's open it up. We got some battery clampy cables. Not sure I'd use those. We can test them out to see how well they fare. Looks like we've got a ground cable. We've got a cigarette lighter style jack cable. I hope we're not supposed to run the inverter with this. It's cracked, it's broken as well. We've got our user's manual. It looks like we've got a remote on off. That's handy. It actually has a little antenna. And some spare parts for the cigarette lighter plug. Alright, and here is the inverter itself. So we've got a 1200 watt pure sine wave inverter. This is a 12 volt DC model. It says it outputs 110 volts AC, which I know several of you guys aren't going to like because you have made it clear that you prefer it to be 120 volts AC. We've got two AC output receptacles or on-off switch. We've got a fault light and a power light. We've got a remote jack. We've got a power delivery USB 2.0 port, 60 watt. I've never seen that on an inverter. And then we've got 1, 2, 3 quick charge USB ports. One's a 24 watt and these two are 18 watts apiece. So we're going to have to test those. I haven't seen this level of USB connectivity on inverters yet. On the back side, we've got some rather smallish DC terminals here. So that screw size is 5.95 millimeters. So M6 bolts for the terminals. That might not be too terrible. I think maybe I have, that's actually the same, roughly the same bolt size that's on this Leesky inverter. Just the terminal itself is a little larger. So it may just be fine. I just haven't seen any that were as maybe these are just really compact. We'll monitor this thermally, see if it's okay. Do you guys just want to open this up right away? Of course you do. Let's try it. See what we got. Okay, and there's the insides. I'm not sure why. One thing I'm noticing right off the bat here is this board is oddly angled. It's not square, but maybe it's not a problem. I see this little plastic box right there. I think that's a little relay that operates off this right here. Like I think I've seen these little kits that you can get separately to control things like that, and it seems like they just kind of glued one in. I mean, they they glued it down pretty tight, so it was fine. And there's those 40 amp fuses, right there and right there, and our fans. Yeah, it just looks a little bit more packed in than a lot of the inverters that we've opened. And then we've got our little display here. Alright, well, let's put this back together and fire it up. So step one to connecting this inverter, take these cables, throw it in the garbage, and then connect your inverter using some real number 2 or number 4 Timco welding cables, and we'll be all good. Yeah, I was going to consider trying those battery clips that it came with, but really, don't even bother. That's just scary. This thing could pull, 100 or more amps, and you don't want to be pulling 100 amps with those battery clip cables. All right, so we're going to hook this thing up to our Time USB 140 amp hour battery. First, we're going to pre-charge. All right, so we're all connected. Let's try to turn this guy on. Got a nice colorful little display right here. Now I wonder if this will work. Nothing. Wonder if we turn it off and then try it. Doesn't appear to be working. Is there not a battery in this? Oh, there's no battery. I don't even know what size battery that is. That's a tiny little thing. Okay, we'll deal with that later. But yeah, I do like this colorful display. I wish companies would make displays that are more readable like this. Okay, so now that we've got it on, let's test. And you guys have been asking for me to get this for a while now, and I apologize that it took so long, but I finally do have an oscilloscope so we can test the waveforms coming out of these inverters. So we're going to test this to see if it is actually pure sine wave. And I'm going to clip on to this kilowatt meter so I can just plug it in and see. And there we go. It is actually a pure sine wave. Alright, so let's plug some loads into this thing and see what it'll do. Let's start off with this AC. Alright, got her plugged in. Let's turn her on. Let's just go straight up high. Now it's not very hot today at all. We finally got some good rain here. So this thing's probably not going to be drawing as much power as we've seen before. Looks like right now we're pulling out about 400 watts. See, on the inverter screen we're showing 12.9 volts from the battery. We're showing 111 volts on the AC output. We're showing 466 watts on the AC output. We're showing 25 degrees Celsius. And on the DC input, we're seeing 590 going in, 46 amps, 12.8 volts. Actually, 12.8 showing there, and we're showing 12.8 here as well. Looks like 520 on the AC output and 620 on the DC input. I think that's putting us at about 80% efficient on this, right? All right, let's do the calculation here. We're seeing about 500 AC out and about, well, 510 AC out right here, and about 617 DC input. Yeah, so that's putting us at 82.6% efficient. So I'd say that's probably about average. Now we've seen, it seems like we were getting about 90% efficient on that Rododo, but of course we had the kind of the strange chirping issues. Not with everything, but when we were running that AC on max for sure. All right, well, I think that, 530 watts, 540 watts is probably the most we're going to get this AC to run today. It's just not very hot out, and so it's just not having to do a whole lot of work. So let's try some other loads. Let's try this heater. And as soon as I plugged that in, I heard a fan come on this thing. But it's not very loud. Yeah, it's not very loud at all. So we're showing 650 watts. Let's go medium on this. Showing 700 watts. So if I go high, which is going to push us over, showing like 1270 watts. Okay, it started complaining. So let's try to find something else to plug in and see if we can push this to that 1200 watts. Uh-oh, we shut down. And it looked like we were just at 1200 watts. Oh, I see what happened. I don't think it was the inverter. I believe it was the battery. We went over, I'm guessing we went over the 100 amp limit of the battery. Okay, now it's back on. Because see, this turned off, and that screen is powered off the battery. So it was not our inverter. Yeah, so let's turn the inverter back on. We might have to double up the battery here. Or actually I could probably just hook up this charger. So we have the battery providing power and we can have the charger kind of boosting our power. Let's do that actually. So I've got the 12-volt charger and the battery, so we should have plenty of power because this will put out like 40, maybe 50 amps. I've actually got it turned down, so probably about 45 amps. This should do 100 amps, so we should be good. Yeah, so you can see we're pulling 84 amps right now, and we're only doing just around 700 watts, and we're pulling over 1,000 watts from the DC side. Our efficiency keeps getting worse. Okay, well, let's turn this on. Oh my goodness. Look at this, guys. We are pulling 1,700 watts from the DC. And we're pulling 1,198 watts through the AC. And this thing just turned off. Let's see if we can turn this back on. I'm going to turn the heater on low. I'm going to try to turn this back on. Okay. So we're showing 1,100 watts on this screen. 1,120. Well, now we're back down to some reasonable amount on the DC side. So 1,340. Well, okay, so I'm wondering if this is not telling me the right wattage. I feel like having this on medium should be using more than 700 watts. Yeah, I don't think this is actually telling us the right wattage. So we're just going to plug in the kilowatt meter to this and see if... I feel like this is going to tell us a different wattage. We're showing 640 watts on low. Like 917 watts on 920 watts really on medium. But look at this. We're showing 705 watts. So we're way off. So yeah, you can't really trust the screen on this guy. So we're gonna have to do this. Let's put this on low. We got 640 watts on low. So remember that's 640 watts. Let's plug in our heat gun. 640 plus 458. So if we plug both of them in, we'll be doing 1,098 watts. So let's do that. All right, so we got both plugged in. We should be pulling 1,098 watts. And the screen right now is actually pretty close. We're showing 1,121, so we're not too far off. It's just for whatever reason when I put this on medium, this does not tell us the right value. Okay, so I guess we'll just let it run at about 1,100 watts roughly and see if it can handle that. But we're doing the 1,346 watts from the DC. Again, doing the math here, we're showing we are at 81.4% efficient. Let's see what the waveform looks like while we got it under this, 1,100 watt load. I'm gonna have to back this plug out real quick. All right, yeah, the waveform looks perfect actually. Let's try some different loads. Let's try a router. This might push us over the edge here. Let's see. I didn't see anything really bad happen to the waveform. It still looked pretty good. When you first turn it on, there was kind of a little bit of noise there. There's a slight glitch. Yeah, I mean, this thing seems like it can handle the loads pretty well. We were doing the 1,100 watts, and it was holding its own pretty well. Doesn't feel super hot. These fans are not loud. Has a massive plus. Let's put it back to doing the 1100 watts between the heater and the heat gun. And then I want to break out the thermal camera and check these terminals to see if anything bad's happening there. Alright, so let's take a look with the thermal camera, see if we can find any issues here. Now I'm seeing 59 is the hottest, and it's not the actual terminals, it's the crimp connector, and it's not that hot. It's just that it's hotter than the terminals themselves, and this is hydraulically crimped, so it's about the best kind of crimp you're going to get. But it's not, you know, 58 Celsius is perfectly fine. So I'm not seeing these terminals getting hot. Yeah, there's no problem. Just a smaller, more compact terminal. Actually not a big, you know, that could be a plus actually, because it's nice to have things that are compact, and if they're not problematic, then that's great. That's really neat. You can see the hot air coming out of that heat gun. You guys see that? Now we're seeing like 42 Celsius on the hottest part of the inverter. And while I've got my tablet out here, I might as well check these USB ports, right? And it says fast charging, so they are better than your standard USB ports. Now I wonder if these work with the inverter off. I think they do. Oh, that's great. That's really good. These continue to function if the inverter's on or off, so you can actually continue to charge things and not have to have the inverter on, wasting power. Fantastic. So what I want to do now is I just want to unplug everything and turn the inverter on and see what the idle consumption is. Alright, so let's just turn it on here. And then let's see what our idle consumption is. Looks like we're drawing about, looks like about 6 watts. It's bouncing between 5.2 to 6.6 to 7.9. So I'm just gonna say around 6 watts. That's pretty respectable. So the only thing that we haven't tested is this remote control, and I don't have a battery that fits that. That's some strange, what size is that even? Some strange size battery that I do not have. So keep that in mind. If you're going to buy one of these and want to use this remote, you're going to have to find that battery. I'm certain you can find it on Amazon. Amazon pretty much has just about anything you can imagine. But I think that's going to be the end of the video on this one, guys. As always, leave your comments. Tell me what you think about this inverter. This is definitely on the real cheap side for a 1200 watt inverter. And I think for that price, it seems like it pretty much functioned quite well. I don't know how long it's going to last or anything like that. So when I get these inverters, I kind of try to use them. You know, I'll try to use it in future videos whenever I'm doing capacity tests with a battery or whatnot. And then that'll give us some idea of, you know, if this thing will last or, you know, if it just blows up when you when you try to use it for some kind of extended period of time. All right, guys, so that's going to be it, and I'll catch you on the next one.